Okay, so we just want to pick back up and do a couple more of these. It says a bin in the electronics department of Building 20, a bargain outlet, contains 100 blank DVDs, of which 10 are known to be defective. If a customer selects 6 of these DVDs at random, determine the probability that 2 of them are defective. So we want the probability that 2 are defective. So that means 2 defective. And then if we're doing 6, that means 4 are not defective, right? And again, because we're talking about a group of 100 DVDs, we can't just say like 2 out of 100, because you could pick of the 10 that are defective, you could pick the first 2 that are defective or the last 2 that are defective. So this is a combination problem. Okay, so let's think about the bottom number first. The bottom number is how many total ways could we choose 2 or 6 DVDs from 100 DVDs. So that would be combination 100, choose 6. And again, I'm okay with you using your calculator to compute that, because it's more about thinking about how to set it up. The top number is going to be 2 things, because we need 2 defective. How many are defective? 10. And we want to choose 2 of them. So that's also going to be a combination of 10. We're choosing 2. And then how many are not defective? Well, if 100 are there and 10 are defective, that means 90 are not defective. So we're going to do combination 90, choose 4. Notice that the top numbers, 10 and 90, add up to 100, and 2 and 4 add up to 6. And then we can use our calculator from there. And so we can check this. Remind me in class if you don't remember how to do this. But you should get like 0.096 as your answer. So that would be like 9.6% chance of that happening. But look at part B. When it says at least one of them is defective, whew, that could be a lot, right? At least one means 1 or more. So that could be 1 or 2 or 3 or 4 or 5 or 6. But could you think of a way that we could do this that would be less work than doing all of those options? Remember, the probability adds up to 1. So what if we do the probability of only 1 or none being defective? No, it wouldn't even include 1, right? 1 or more would just be the probability that none are defective. If we could figure that out, could we take 1 minus that to get this answer? You see how that would be less work? I mean, you could totally do it the other way, but I think we should do the probability that none of them are defective. So again, my bottom number is going to be of 100, I'm choosing 6. But now my top number is of the 90 that are not defective, I want to choose 10 of them. Not 10, goodness gracious, 6 of them, right? If you want, you could say of the 10 defective ones, you're choosing 0, but you don't have to include that part because it's just 1. Does that make sense where I'm getting that? And again, I'm just going to use my my calculator to get that, so bear with me for a second while I type it in my calculator. I believe that that's 0.522, and then I get 0.478 as the answer, or 47.8%. And then the last one here is kind of a cool question. It says a group of 5 people is selected at random. What's the probability that at least 2 of them have the same birthday? Now, in order to do this problem, we have to make some assumptions. One of them is we have to throw out the fact that every 4 years there's a leap year. So we're going to throw out that no one's born on February 29th, since that only happens sometimes. I guess you could use 366 days if you want to include that. Not 360. Yeah, 366, right? So first of all, let's figure out how many total ways that this could happen. So the group of 5 people, each one, their birthday could end up on any day of the year, right? So like the first person has the option of 365 days. The second one has an option of 365 days. Like I think that the bottom number is 365 to the 5th power. If you think about each person has that many, like there's that many options for each person's birthday. And then the top number, we want to find the probability that at least 2 of them have the same birthday. So again, think about this at least 2. That means it could be 2 or 3 or 4 or 5. But what would be the opposite of at least 2 of them have the same birthday? What if we figure out how many ways that none of them share a birthday? And if we did that, just like on the last problem, could I take 1 minus the way that they don't share a birthday, and then that would give me how many ways they could share a birthday? So how could we show that they don't share a birthday? Well, think about the first person. 1, 2, 3, 4, 5. That first person has 365 days that could be their birthday, right? But now the second person can't share a birthday, so that's 1 day less. So that's going to be 364 days. And then they can't share it, so it's just going to keep counting down. 363, 362, 361. There's going to be some crazy numbers, right? The chance that they have different birthdays is going to be really, really high. Like if I do this, I get 1 minus 0.973. Pretty good chance that 5 people don't have the same birthday. And so then when you subtract that, you get 0.027, or only 2.7% chance that they share a birthday. Your book talks about this a little bit more. It's kind of cool. They have this whole table in there if you look at it. It's pretty cool. All right, we'll practice this more in class.